Open your book to page 22. Okay. Today's lesson is about trigonometric ratios and right triangles. So first, it kind of review a little bit of Pythagorean Theorem. So this one is something that you should know already. Again, you encounter this many times. So on page 22, you have a right triangle, and you have the A, B, and C. So when you have right triangle, the relationship between the three sides are A squared plus B squared equal to C squared. So again, we're not going to spend too much time on this. Okay, so you guys should know this already. So on example 1, you have this triangle over here. You got 27, 23, and H. And so example 1 says find the area of the triangle. So you can use Pythagorean Theorem. So you got 23 squared, right? A squared plus B squared equal to C squared. So again, in order to find the area, you need to find the height. So I'm not going through the details, so you can work it out. So So this one equal to 14 feet. And then they kind of run it out to 14 feet. So area equal to 1/2 base times height. You can write down the formula, and then you substitute the numbers. So area equal to 1/2 base times height. I'm going kind of fast because this is very basic stuff. You guys should know this already, right? And so get your calculator and you work it out. So 160 square feet. So you can just kind of quick review on Pythagorean Theorem. Okay. Now let's go to page 23. Page 23, it talks about trigonometric ratios. So you have a right triangle, and you have an angle right over here, and you have the A, B, and C. So there are different ratio possibles. For example, you can have, so there are 6 possible, right? So you got A over B, and you can have an A over C, right? Then after you're done with A, then you can do the B. So you can have B over A, you can have a B over C, right? Then after that, after you're done with the B, then you can go C, right? So you can have a C over A, and you can have a C over B, right? So there are 6 different ratios, 6 different ratios. Now, these 6 different ratios are very special, so you have a name for each one of these. So if you go to the yellow box on the bottom of page 23, okay, so now this is the abbreviation for sine, S-I-N-E, sine. Okay, so sine theta is the name of the ratio for B over C, or equal to opposite over hypotenuse. So sine theta is B over C. So again, that's the name for this ratio. And cosine theta is a complement of sine. Okay, that's what it says. So it's A over C, and so this is adjacent over hypotenuse. And then you have the tangent theta. By the way, tangent theta is same as the slope. Okay, so slope is vertical over horizontal, so it'd be opposite over adjacent. So these are the 3. Now the other 3 are the inverse functions. So you just kind of flip it over. So CSC, this is called a cosecant. Okay, all the names are right above the yellow box. So if you want to know what each of these is, right, you go right above. There's a paragraph above the yellow box. It says these ratios are referred to as the trigonometric ratios, and because of their importance, each is giving a name. Okay, so SINE, sine, and cosine, tangent, cosecant, secant, and cotangent. And each is written in abbreviated form as follows. Okay. So again, if you want to know the spelling, you go to look at the paragraph. So cosecant is a reciprocal of these. So it's equal to C over B. Notice that they go as a pair, right? And so this is equal to hypotenuse over opposite. And secant is reciprocal of this, so it'd be C over A equal to hypotenuse over adjacent. And cotangent is a reciprocal of this one, so it'd be A over B, so it'd be adjacent over opposite. So you need to memorize these 6 ratios. So you can use whatever method. Okay, you can put on an index card and use a note card to memorize it. Or you can come up with a way to memorize it. Like you can use an acronym, right? So this is so like SOH, right? So sine is opposite over hypotenuse. And this is cosine. Cosine is equal to adjacent over hypotenuse. Okay, and tangent, okay, use a calculator. So tangent is opposite over adjacent. So you can go SOHCAHTOA. So that, again, that's one way of memorizing it. Okay. The way I memorize it is the way I memorize sine. Okay. I think of the sign, the SIGN sign. So I think about like a stop sign. Okay. So stop sign is vertical, right? See up and down. So that's how I remember that the sign is up and down. It's vertical over hypotenuse. Okay. And cosine, I think about car run over the sign, like car over the sign. So it not down, it's horizontal. Again, so you come up with the crazy ideas, crazy stories to help you to memorize. So those are like memory devices. Okay. And tangent is a slope, so it's vertical over horizontal. Okay. So you can come up with a way to memorize these 6 ratios. All you need to do actually is memorize the 3. If you memorize the 3, the other 2 would be just reciprocal. Okay? So just flip it over. And if you notice, each pair has one cofunction, right? This one is sine, and this is cosecant, right? So each pair has a complement function. So that this one is secant, this is cosine, right? Tangent and cotangent, right? So each pair has one co and one non-co. Okay? So if you have like a cosine and cosecant, then it's wrong, right? Because both are co, right? So again, each pair has one complement function and complementary function, the other one does not. So you need to memorize this. Okay? So it's very important. So you can come up with a method to help you to memorize it. Okay? Okay. Now, the next thing is you need to know how to use a calculator to evaluate functions. So I'm going to use my calculator, but when you have different calculator, I will come and help you after I give you the assignment. So let's go to page 26, and let's go to example 2. A. So you have a sine of 23.72 degrees. So the way to use this is, so if your calculator has a direction arrow, you need to enter the function first, then the degrees. This one is a cheap calculator, does not have the direction arrows. So this one you enter the number first, then the function. Okay, so like this one, so I go 23.72, and this is sine, so I push in the button sine, and that's my answer. So answer is 0.4023. Normally you get 4 decimal places when you're doing the trig function. Okay? And let's go to another example. Okay, let's go to when you're going backward. So let's go to example 3. So page 28, example 3. Again, I'm just kind of go over very briefly because each one of you may have a different calculator. So I will come and help you with your calculator when you have to do this. Okay. Okay. So let's go and do A. So you have cosine theta equal to 0.7335. So notice over here they give you the degree. They give you the angle. You're looking for ratio. So it's straightforward. Now when they give you the ratio, and you're looking for angle, whenever you're looking for theta, you're looking for angle, you have to go backwards. So you have to use the second function. So in this case, okay, notice what I do. Okay, so enter the number 0.7335, and I go second. I see the bottom of here, so I go second cosine. Okay, use a second function to go backward. So again, whenever you're looking for angle theta, you always use second function. If they give you the angle, you just go straight forward. Okay? And so the answer would be 42.82 degrees. Okay, so that's it. Okay, now when you have a, let's see, when you have like a secondary function that is not on the calculator, notice the calculator has only sine, cosine, tangent. So when you have this, so when you have secondary function, this is called a primary function. These three, sine, cosine, tangent, these are primary functions. These three are secondary functions. So you need to know how to do that. Notice that you don't have that on the calculator. So I'm going to show you how to figure out these on the calculator. Okay? So if you go to the homework page. So let's go to like page 31, and I'm going to go to like do some evens. So like number 18. You're looking for cosecant of 22.5 degrees. So now if you go on your calculator, notice there's no cosecant. Right, everybody see that? There's no cosecant. So what you need to do with this is that first, you need to realize that cosecant is a reciprocal of sine. So first you need to convert this into 1 over sine of 22.5 degrees. And what you want to do is, so let's go and figure out the sine of 22.5 degrees first. So 22.5, and oh, by the way, you have to make sure that this is in degree mode. Make sure your calculator says DEG. If it says RAD, you're in the wrong mode. Okay. So again, later on we're going to cover more about degree and radian. But right now, make sure your calculator says DEG. Make sure it's in degree mode. Again, when I will come around and help you guys with this calculator. Okay, so you enter the number, you push sine. Okay, so now it's 1 over that. So notice on your calculator, there's a button over here that says 1 over x. Everybody see that? Right over here. So some of you have this button over here. So this is how you flip things upside down. So right now this is over here. So 1 over that, you push this 1 over x button, and that's how you get the answer. Okay, so answer would be 2.613, and that's your answer. Again, don't worry too much about right now. Again, when I give you the assignment, I will come around to help you guys. Okay. Okay. Now, next thing you need to know is, let's go to example 5. So let's go to page 29. Example 5. It says solve a right triangle. So you have this picture over here. So make sure you draw big, nice triangle so you have room to label everything. So this is 51.3 kilometers. This is 42.7 kilometers. And this is A over here. Okay, solve. When it says solve the right triangle, when it says solve the triangle means you're looking for all three sides and all three angles. So normally what you want to do is, you just go and write down the A, B, C. Capital letters are angles, small letters are side. So normally a good idea to just go and get everything all together. So over here you know that, okay, so this is A, so that's a B, right? And this is C. C is always hypotenuse. And capital A is always facing small a, and capital B is always facing small b, and capital C is always facing small c. So from here you know that this is 90 degrees, okay? And A you don't know, B is giving, it's 42.7 kilometers, and C is 51.3 kilometers. Okay? So what you want to do is, whatever you're looking for, right? You want to write that first. And so basically whenever you solve, right, the key to do is the unknown over what's given, okay? And equal to function. So usually that's the formula you want to write, okay, when you try to solve something. But anyway, so first, let's go and use Pythagorean Theorem. We know these two sides, and it's a right triangle, so you can use Pythagorean Theorem, okay, to solve that, okay, if you want to, okay. But since this is a practice on trigonometric ratio, that's not using the Pythagorean Theorem, okay. Let's just practice with our trigonometric ratio. Okay, so again, so unknown over giving equal to function. That's a format. So let's go and look for A. So we're looking for A. Well, actually, we have to look for the angle first. Let's get the angle first. So let's go and look for the angle first. So again, these two are giving. Okay, so let's go and use these two giving to find this angle. So B over C, and if you remember, well, you don't know that yet, but you have to know that, right? So from here, the B over C is sine. Okay, so this is equal to sine of theta, in this case sine of B, right? So this is your theta right over here. So let's go and call this theta. But remember, theta is also your B, right? So you put in the numbers, so you got 42.7 over 51.3 equal to sine theta. Now remember, whenever you're looking for angle, you have to go backward, you have to go second function, right? So this is what I'm going to do. I'm going to go 42.7 divided by 51.3. Now make sure you push equal. Okay, now you're going to look for angles, so you go second sine. So that's my theta. So theta equal to 56.34 degrees. Okay, so this is 56.34 degrees. So this is 56.34 degrees. Again, keep all your information together so it's easier to kind of figure it out. So once I found B, now A and since this is a right triangle, A and B are complementary angles. So just minus 90 from that. So I'm going to minus 90 and take the opposite. So I get 33.66 degrees. Okay. So now to figure out A, I can use A over C, right? Again, I'm looking for A, so I write that first. And C is giving, right? So A over C. So A over C is equal to cosine theta. Right? So again, write down your, so A over C, that's a cosine function. So again, write down your formula, right? Again, unknown. So whatever you're looking for, you always write that first. It's much easier to do. You don't have to, but this is much easier to do. So whatever you're looking for, you write it down first, and then what it's giving, and based on that, you can figure out the function. Then after that, you put in all the numbers. So A over 51.3 equal to cosine of 56.34 degrees. Cross multiply. Okay. And then go and get your calculator and you're punching the numbers. For this calculator, I like to kind of work backward. So 56.34 degrees, take the cosine of that, times it by 51.3, push equal. So A equal to 28.4 kilometers. Okay, and so that is your answer right over here. Okay, so you can keep everything organized, so easier to follow, and that way it's less likely of making mistakes. Okay, actually, yeah, you don't want to box this over here. Yeah, let's not box this here. So keep everything up here, so you don't need to box this down here. Let's not box it over here. Okay, there you go. So box this up here. Okay. Okay, so let's go and do some practice, and I will come around to help you guys with calculator part. Okay, let's see.